have you here to learn about the national parks this week. My name is Ms. Weisenstein and I'm an earth science teacher in Southern Illinois, and I'm excited to talk to you about our next national park, Joshua Tree National Park, which is located in Southern California. Quick facts about Joshua Tree National Park. It became a national monument in 1936 and was established to really protect the plants, the unique cactus, Joshua trees, and wildflowers that are found in that area, and was upgraded to a national park on October 31st, 1994. The park gets about 2.9 million visitors each year, and it's a really great place if you're visiting Southern California. It's a really easy drive, 1 to 3 hours from pretty much anywhere in Southern California, so go check that place out. So Joshua Tree National Park, what is even a Joshua tree? If you take a look at these pictures, these are examples of Joshua trees, and they are only found in this area of the world, in California, Utah, Arizona, and Nevada. So this is a really unique ecosystem that you can come and see here, as obviously you can tell it's a desert and they like really dry areas. The tree is actually a type of yucca plant and has these spiky evergreen needles, like leaves, on the end of the tree. And really unique about the Joshua tree is it can only be pollinated by one type of moth. More specifically, it's only pollinated by the female moth of one species. So without that moth, the Joshua trees wouldn't be able to pollinate. The Joshua Tree National Park is obviously well known for the Joshua trees, but it's also really popular for rock climbers. There's a lot of really neat geology, and I don't normally give you all of this information in these videos because I really want you to think about how the geology formed. But this week we're going to focus more on the earthquakes and why the earthquakes occur in Joshua Tree. So I didn't want to leave out this really cool information about how some of the rock features formed. So here's a snapshot of the geological history of Joshua Tree National Park. So the Farallon Plate subducts underneath the North American Plate, and it's the ancient Farallon Plate. We don't have this plate anymore, as most of it has already subducted under the North American Plate. As it was subducting, the gases and water heated from the Farallon Plate, causing the North American Plate to partially melt and form magma in the crust. That magma, though, didn't reach the surface to form volcanoes, but it cooled and hardened under the surface, forming intrusive igneous rock. Specifically, most of it is granite. So over time, those magma intrusions that had cooled and now are granite, they're still getting a lot of pressure from that Farallon Plate subducting. So it caused the granite rock to crack and break under all of that pressure. Over time, groundwater was able to seep into those cracks and break that down even more until where you get like big pieces of rock that were forming underneath the ground. Well, when the surface was eroded and weathered away, what you're left with are what look like piles of rocks, but they naturally formed like that. They appear like people kind of stacked them up, but that's not what happened. It was naturally occurring piles of rocks. So all those rock features that are formed in Joshua Tree National Park are really, really great for rock climbing. But this week, we're not going to so much focus on how the rocks formed, but rather we're going to focus on how the crust is moving there and why are earthquakes occurring in Joshua Tree National Park. Specifically, there was a larger earthquake that occurred last summer that occurred in Joshua Tree National Park that we'll talk about later this week. So some things that you can look at, think about and investigate about Joshua National Park and related to earthquakes and seismic activity include finding the epicenter and focus of an earthquake, different type of faults, how is the earth moving, how is the crust moving along faults, what's actually causing earthquakes, reviewing different types of seismic waves, earthquake safety, what happens if you get caught in an earthquake, and lastly, seismic activity due to humans. So how are humans causing seismic activity, and how does that change, especially right now while we are, a lot of us are in shelter in place and we're not really supposed to be leaving our homes. So how is that changing the seismic activity around the world? I hope you enjoyed this video, and I will see you again next week.